So the next thing I want to talk about are reflections. So we have two types of reflections. First is across the x-axis. And the way we do this, we take f of x, multiply it by -1 or attach a minus sign to it. Now, if you're going to reflect across the y-axis, take f of x, you attach a minus sign onto the x. So that's how you reflect across the y-axis. So let's look at some examples. So let's say we have our function, again, f of x equals x squared. So in this case, what we're going to do, we have our x and our f of x. Here's a minus f of x. And then we'll have our new ordered pairs. So this is a reflection across the x-axis. So again, let's go with -2, -1, 0, 1, 2. And again, we're just squaring these x inputs. So we have 4, 1, 0, 1, and 4. So to do a reflection across the x-axis, attach a minus sign to those outputs. We have our inputs, we have our outputs, switch the sign on the outputs. Again, we'll leave the x alone. This will become -4, -1, 0. I mean, 0 is just anything times 0, 0. -1, -4. And so this gives us the ordered pairs -2, -4, -2, -1, 0, and 0, 1, -1, 2, -4. So what's happened? Well, we've only modified that y coordinate, or that second coordinate. X is still the same. Oh dear. But the y has been modified. The original ordered pair would have been -2 and 4. Now it's -2, -4. -1 and 1, -1, -1. All right, 0 and 0, that doesn't change. 1 and 1 is now 1 and -1. 2 and 4, 2, -4. So let's graph the old ordered pairs with these new ones. Let's see what this looks like. So if we graph well, the original ordered pairs, -2 and 4, 1 and -1, 0 and 0, 1 and 1, 2 and 4. So those are the original ordered pairs. Let's look at the modified. So that was -2, -4. -1 and -1. 0 and 0, that didn't change. 1 and -1, 2, -4. So this would be a reflection of this across the x-axis. You can think of this as a pool, and the parabola is looking at its reflection in the pool. But that's how you would do that. You just attach a minus sign to the y-coordinates of the original function. That will flip it across the x-axis. Now let's take a look at reflection across the y-axis. Now, for us, the parabola is not really going to work, because if you reflect it across the y-axis, it's like having the parabola spin around on the y-axis, and you just get the same shape. So let's try a different function. Say we have this one. Now, we know this function. You recall this canonical function. Square root of x. It's like this. So reflecting it across the y-axis means we're going to make it look like this. So let's see how this works. Now, I want to be careful here, taking square roots. So we have some limits. So x, can't put any negative values in there. We can put in 0, 1, 4, and let's go. We better stick with those, just to make sure our graph fits on the board. And then f of x. Well, that's just the square root of these. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. So there's an ordered pair, ordered pair, ordered pair. But now, f of x, we're going to attach a minus to it. That becomes square root of minus x. So this might seem pretty troublesome. We just put a minus sign in a square root. And you'd be right, that would be troublesome. So what we're going to do, this actually does have an effect on the choice of x. This one actually does. So what's going to happen here is we have to look at this function and say, well, what values of x can we actually use? And so this becomes a problem. So for this function, if we put a minus on the x, because f of negative x is square root of negative x. If we put positive numbers in here, we're going to get the square root of a negative sign attached to a positive. That's the square root of a negative number. And since we're keeping this to just real numbers, that means we can't get square roots of negative numbers. Not going to work. This forces us to change the domain. So instead of using like 0, 1, and 4, we have to use 0, -1, and -4. Negative of -1 becomes a positive. -4 becomes a positive form. So for this, we do have to look at the domain. So let's take a look. Now, 0, -1, -4, f of minus x. So square root of minus times 0, well, that's just going to be square root of 0, 0. Square root of minus -1, you get that double negative there. That's going to be the root, square root of 1, or 1. And then for this one, square root of -4, that's the square root of 4, or 2. So in this case, we put f of negative x 0, 0, -1, and 1, -4, and 2. And if you've noticed, we're using different x's than from originally. So this time we do have to use a different x. So let's graph it. The original function was square root of x, and we had the points 0, 0, 1, and 1, 4 and 2. We connect those dots, we get something like that. For the other function, f of x, or f of negative x, equals square root of negative x, we have to use different x values in this case because of domain. We don't want to take the square root of negative numbers. If you have, say, square root this, you have a 1 here, you get the square root of -1, not going to work. You have a 4 here, square root of -4, again, square root of a negative number, doesn't work. But negative of -1 becomes positive. Negative of -4, that becomes +4. We can take the square root of +4. So just to kind of recall what we did, for this function, we had to use these values. When we did, we still got 0, 0. Then we have -1 and 1, -4 and 2. And there you go. All right. Let me do one more. Now, this function, we're going to do another reflection across the y-axis. And with this function, domain's not really going to be an issue. Let's say we have f of x equals x cubed. So with this one, so again, let's go with numbers. Now, f of x is x cubed. We just cube these. So the cube of -2 times -2 times -2, that comes out to -8. -1 times -1 times -1, -1. 0 times 0 times 0 is 0. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. Now here, we're going to get this minus. So f of minus -2, which will be f of 2, which equals 8. Squeeze in that 8. Here we have f of -1, which is f of 1, or +1. F of -0, f of 0, squeeze an f of 0 in there here. Which is 0. F of -1, I'm sorry, negative applied to 1. F of -1, or just 1. Well, that's very easy to see. We'll be a little better on that one. With the lines closing in here. So f of -1, f of -1, which was minus 1, not 1, minus 1. And then f of minus x is 2. F of negative 2 or negative 8. Ooh. Let me clean this up for you. I think it's a little hard to see on camera. So what's happening here, x is negative 2. And then when we do f of negative 2, negative 2, we get an output of 8. For this one, x is negative 1. So f of negative minus 1 becomes f of 1, which is equal to 1. F of negative to 0, well, that's just f of 0. That's 0. And then f of minus applied to 1, that's just f of negative 1, which is negative 1. And then 2, negative applied to 2, f of negative 2, negative 8. So the old coordinates, negative 2, negative 8, is now negative 2 and 8. Negative 1 is now negative 1 and 1. 0 and 0 is now 0, so I'll have to change. But 1 and 1 is now 1 and negative 1. And then 2 and 8 is now 2 and negative 8. Let's graph these. These ordered pairs, those ordered pairs. So for the original function, negative 2 had an output of negative 8. Negative 1 had an output of negative 1. 0 had an output of 0. 1 had an output of 1. And 2 had an output of 8. So what we get is that. Now for the other ordered pairs. Negative 2, we have f of negative x. Negative 2 gives you an output of positive 8. And 1, negative 1, gave you an output of 1. 0 and 0 is there. 1 gave you an output of negative 1, and 2 gave an output of negative 8. So if we connect these, we're going to get this. And as you can tell, say, look at this top part, kind of forget the bottom, this is a reflection of each other. And down here, these two cover at the top part, these are reflections of each other. So again, that's how you do reflection across the y-axis. Any question? Let me know.